a speed? Let us see. Speed means it is defined as the rate of change of distance known as speed of the system, and whereas velocity is defined as the rate of change of displacement produced by the object, that is called as velocity. Now both parameters contains same units as meters per second, and dimension formula m power 0 lt power minus 1. Now the question is that how can we differentiate the speed and as well as velocity? So speed and as well as velocity, it requires only positive values. It chooses positive, 0 and as well as negative values. It is always a scalar quantity. It is a vector quantity. Speed need only a magnitude of the system, whereas velocity require both magnitude and as well as direction. These are the primary differences. And at any point, the speed of the object may be greater than or equal to that of velocity of the particle. So these are the important things we have to remember, the differences and the condition between speed and as well as velocity. Let us explore one or two examples so that you can understand properly. Speed and velocity. Example 1. Suppose this is the x-axis. Here x is equal to 0, x is equal to some 10 meters, x is equal to 20 meters. This is happens up to some x is equal to 50 meters. Now a block initially starts from x is equal to 0, travels to x is equal to 50, and then return to x is equal to 20 meters per second. Now from this particular point is called A, this particular point called as B, this particular point is called as C. Now the total distance given by A to C plus C to B, which is given by 50 plus 30, which is equal to 80 meters, is the total distance of journey. Whereas when you consider total displacement means the gap between the final position and as well as initial position. So therefore you can write down 20 minus 0, which is equal to 20 meters. This is the total displacement. Now let us consider the time taken to complete from A to C and then B, the total time of journey, capital T, given by, let's say, 10 seconds. Then the speed of the system is given by 80 by 10, which is equal to 8 meters per second, and whereas velocity of the object is given by 20 by 10, which is equal to 2 meters per second. In the examination, the important thing is that, sir, what is the basic formula we have to consider in calculation of time of journey? In calculation of time of journey, 99% of problems involve with calculation of speeds only. Anyways, we will see one more example. Example number 2. Imagine that here is something like a building having cross section in the form of U shape like this. The building cross section idea like this. Now length of each side from here to here, from here to here, or from here to here, any side is equal to L, 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 and the time taken to complete each length L is nothing but T, T, T. Then the total distance already we computed in the previous case, Total distance is nothing but 3L, and the time of journey, which is equal to t plus t plus 3, is called as a 3t. Therefore, in this case, the value of speed is given by 3L by 3t, both just cancel, we got the value of L by t. And displacement of the system is equal to, imagine that this is the starting point and this is ending point. Object will move like this. So the vector form is nothing but a straight line from starting to ending. This gap is exactly equal to L. Therefore, displacement is L. And the time taken to complete this entire thing is nothing but 3t. Therefore, by using this data, velocity is given by simply displacement by time of journey. So we got 1/3. So 1/3 of L by t. Like this we can consider. We'll see one more example. Example number 3. Imagine that there is something like a circular trajectory like this. Let us try to change the font like this. Okay, this is the circular track. Now initial object is here. Right now it travel up to this particular position. Then, so how can you calculate the speed and as well as uh, velocity during this particular case? When you try to extend the lines, they will try to meet at this particular place. It is about pi by 2 radians. Imagine that the time of journey from here to nothing but some t seconds. Let the radius of the system is nothing but r. Then distance is equal to radius into angle at the center. Therefore, r pi by 2. And the time of journey is nothing but t. By using this data, speed of the particle is given by r pi by 2t. Whereas the velocity of the particle is given by displacement. So when you try to join like this will become something like a hypotenuse here, r, and this hypotenuse becomes a root 2 into r by using Pythagorean theorem. Therefore, root 2 into r. Time of journey never changes, it's the same, t only. So therefore, velocity of the particle is given by simply root 2 into r by t. So by using the information like this, one can determine displacement and as well as one can find out the speed of the system and as well as the velocity of this particular particle. In some other cases, we need to face like a instantaneous speed, average speed, or instantaneous, like that. Some different type of terminologies are given in the problem. Then further, the speed of the particle further divided into two stages. First thing is called as instantaneous speed. Next one is called as average speed. Okay, we have two type of speeds: instantaneous speed and average speed. Instantaneous speed means v is equal to, simply you can write down dx by dt, where x is a function of time. They will give you some value here. You have to do differentiation and you need to find out the value of speed upon substituting the value of t in the given differential equation. Let us see. X of t is equal to something like 3t square plus t seconds, meters. Let us take this is the distance, changes according to like this. We need to find out the speed of the particle at t is equal to 2 seconds. Then you have to do differentiation. Upon doing differentiation, we got d by dt of the given distance function is nothing but 3t square plus t. Upon doing differentiation, 3 into dt by dt square plus d by dt of t, which is equal to 60 plus 1. What now we need to find out the speed. So they've substituted the value of v here in the given problem. Therefore, v is equal simply 6 into 2, 12 plus 1, that's called as 13 meters per second. Like this, we can find out the instantaneous speed of this particular particle. However, It is defined as the speed of the particle at that momentary of time. Example, if we are moving from one place to another place, then the speedometer reading, sometimes it is fluctuating from 10, 20, 30, sometimes it will decreases like a 20 or 10, sometimes it will raises like 40, 60, like that. So what are the numbers that you are expressing the speed corresponding to a particular position? That is called as instantaneous speed of the motion. The next thing is average speed. So average speed is nothing but the total distance of journey to the top, total time of journey. This particular ratio, this is called as average speed of the system. Further, the calculation of average speed divided into three particular methods. We will see in the next slide. Average speed or mean speed. This can be computed by simply using three particular methods. In these three methods, number one, in the examination, the total journey divided into different parts S1, S2, dash 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 Sn and T1, T2, dash 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 Tn, like this given. Then how to find out average speed? Average speed is determined using formula delta V is equal to summation of individual segments like distances sigma Si divided by total time sigma Ti. This particular ratio will give you simply average speed. In some calculation, examiner would like to give you speed of the particle in the given interval of time v1 t1, v2 t2, dash dash dash, vn tn given. Then in such a case, average speed is equal to, we need to calculate total distance actually. So the distance traveled in the first segment is nothing but speed into time. I am repeating one more time. Distance traveled in the first segment is nothing but speed into time. Therefore, you can write down as v1 t1 plus v2 t2 dash dash dash. That means you can write down as sigma vi ti divided by total time of journey is nothing but sigma ti. On the other hand, in the examination, sometimes examiner will like to specify with the speed of the particle distance covered. Like this, they will give you v2 s2 dash 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 vn sn, like this given. Then total distance of journey means sigma si. That is the total distance s1 plus s2 plus dash 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 sn, called as sigma si. I need time. Time of journey. Time of journey. Actually, speed is equal to what we write down here. Distance by time. Upon doing cross multiplication, we got distance by speed. That means sigma s by vi. So s1 by v1 plus s2. Like this, we have to be taken. Now, at this case, iterate for uniform motion. Very important thing. This is for, now we are calculating for uniform motion. Uniform motion means regular intervals of a time produces regular distances. Then S1, S2, S3 all are equal, T1, T2, T3 all are equal. In such a case, V is equal to, you can take simply S by T. In this particular case, average speed of the particle given by regular intervals is, so therefore we can take care of V1 plus V2 plus dash 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 Vn divided by n we have to take. In this particular case, average speed is equal to, so regular intervals with the regular speeds we can take. Therefore, Vi, whatever the Vith particle, that is obviously the correct answer. So like this, we have to be take care in this particular case. Further, there is an important instruction. Please look at here. Now, in this case, we have only two segments like this. V1 T1, V2 T2. Then in such a case, average speed is equal to simply V1 plus V2 by 2 we have to take if the time intervals are same with the different speeds. Time intervals are same with the different speeds. Now, for this case, so we have the segments like this V1 S1, V2 S2. Let S1 is equal to S2. Then the average speed given by 2 V1 V2 by V1 plus V2. So like this, we have to be compute the concepts of average speed in the three different modes. On the other hand, in the examination, there is a possibility over the concept of average speed by intermixing the second formula and as well as third formula. So we have to take care of an important condition, that is, how can we use interpretation between the any two different kind of mode of formulas. Suppose this is the interval what we have. First half of the distance s travels with a speed of v1. Second half of the distance traveled in the equal interval t1 t2 times. That means t and as well as t equal intervals of time with the speeds of v2 and as well as v3. Then what is the total average speed of the system? Let us try to compute. First half of the journey travel with a speed of v1. Second half travel with equal intervals of time. That means from here to here, how much amount of time? The same time is taken from here to here. Because of different speeds, distance covered will be obviously different here. That's the logic. Now, in this particular example, one should focus for the second part first. For this particular second part, let VO be the average speed. Then, what we write down here, average speed is equal to simply V2 plus V3 by 2 because equal intervals of time. Let us see the previous slide. Here, V1 plus V2 by 2 equal intervals of time, 2 segments. We have to use this formula. So we got the V. Therefore, the problem can be reduced to like this. The speed of the particle is V1, first interval half. In the second interval of half of the distance, we have the speed of VO. Equal distances are there. Then, when equal distances are there here, we have 2v1 v2 by v1 plus v2 is a direct formula. So therefore, you can implement here to find out this. We have average speed of the system is equal to here 2v1 v0 by v1 plus v0 we have to write down. So upon solving this, we have 2 into v1 into v0 means v2 plus v3 by 2 whole divided by v1 plus v2 plus v3 by 2. So in this particular case, upon solving the center equation, we are going to obtain equation 2v1 of v2 plus v3 whole divided by 2v1 plus v2 plus v3. By using this particular formula, one can determine average speed of the system. Now, let us consider the one more example so that you can understand the concept of average speed. For example, we have something like an equilateral triangle having side of A, and A each. Now, in this case, a person is walking from point A, B to C and then simply he halts. During this process, he consumed some time of say some A by 2 seconds total. Then we need to compute average speed. To find out this average speed, we have to use formula. Average speed is nothing but total distance A plus A. How much it is? 2A. And what's the time of journey from here to here? Here to here. Time of journey is given by A by 2 seconds. So A by 2 cancel. 2 goes numerator. Therefore, 4 meters per second is the right answer. Now, we'll see one more example. A person is moving along the x-axis like this. Now A, B and C. These are the segments what we are considering during this case. Now, at a point of B, when you try to observe the distance from here to here, let us say is a 10 meters, from here to here 30 meters. Meanwhile, from A to B, he taken care of for some 10 seconds of time, and B to C, he taken care of something like 40 seconds of time. And at B, he spent, say, some 10 seconds of time for relaxation purpose. Then how to find out average speed? Total distance of journey means 10 plus 30, 10 plus 30, and the total time of journey will be 10 plus 40. Is it correct? Wrong. Because 10 seconds is a part of the journey where he halted. Therefore, the 10 seconds also be included in the problem. That means here we have 40 by. So 40 plus 10, you can write down as 60, cancel. Therefore, average speed is nothing but 2 by 3 meters per second is the right answer. So, after completion of this, let us try to enter into the next concept, that is average velocity. So, how to find out velocity of x bar we have to take, and average velocity means total displacement to the top, total time of journey. These two definitions are valid, similar to that of instantaneous speed and as well as average speed. That's it. Now, whatever the method we followed, the same three kind of methods are implemented here in calculation of average velocities. That depends on either displacement time combination or velocity time combination or velocity and displacement combination. Whatever the combination given in the problem, that has to be used similar to that of the previous cases only. Okay. Now in the examination, how can you identify that this particular case? Only direction is very important here. In addition to the magnitude, we have to find out direction. That's it. Let us see some example. Suppose in the general way with the standard notations, a particle is going towards east about 100 meters in 20 seconds, and then north 100 meters about 40 seconds. Then how can we find out average velocity during this particular case? So upon simply preparing the geometry like this, head is north here, this is east, south and as well as west. Now a particle initially moved towards the east, means towards this direction. So therefore this is called x1 bar, and then it travels along the north. So therefore towards the north, this is x2 bar. We have the two vectors. Now the resultant of these two vectors is nothing but this particular one is nothing but x12 bar is called as resultant. So in this case x12 bar, the resultant vector is equal to x1 bar plus x2 bar. What is the value of x1 bar here? This is not the relative. Please remember, this is not the relative. This is the resultant of x1 and as well as x2. x12 is the resultant. Okay, right. It is not the relative. It's the resultant. Now, x1 bar means what we write down here? x1 into I plus x2 into j. So, x1 means 100I plus 100j. Therefore, you can write down 100 common. You can write down as I plus j. That's the total displacement we got in this problem. Now, we have to find out the total time of journey. Total time of journey is nothing but a t1 plus t2. Directly we can write down 20 plus 40, which is equal to, you can write as 60. Therefore, average velocity, which is given by 100 by 60 of I plus j, which is equal to 5 by 3 of I plus j meters per second. This is called as average velocity of the system. So the only difference is that we have to do something like a vectorial approach in calculation of average velocities, and then we will get the right answers. Okay. Now, in the next case, how can we identify velocity is positive, negative, or zero? Let us see. Note. Number one, if
displacement of the particle is equal to 0, then velocity becomes 0. There is no doubt. Perfectly described. Means objects transform origin upon reflection to the same point, total displacement becomes 0. In this case, average velocity becomes 0, whereas average speed cannot be 0. Second, now this is the origin. Origin means a starting point. This is called ending point, and this is one more ending point, and this is ending point, and this is one more ending point. I am considering all directions. Now, towards this side means positive x direction, positive x direction. Then it is positive, velocity is positive. That means if I say more clearly, simply we can write down as this is plus v, or plus v bar you can write down. Now, at this particular case, if the final position is backside, then you can represent it as minus v bar. If the object is coming in the downward direction, that is called as minus v bar. Moving in upward direction, called as plus v bar. To differentiate among x-axis and y-axis, what we have to do is we have to give a small suffix. That means here vx, here vx, this is vy, and as well as vy. Like this we have to be given. Now let us see an example so that you can understand. This is the vertical ball. Here is the ball which is projected like this with the speed of something like u, and reflect back with the speed of v at an angle of alpha. Here angle is nothing but theta. What is initial vector and what is final velocity vector? Somebody will ask. Then upon resoluting like this, we got this is nothing but v cos alpha, and this is nothing but v sin alpha. So therefore you can write down as v bar is equal to v sin alpha acting in the minus x direction, therefore minus x, plus v cos alpha into minus j. So as per the same sign convention, so I'm using here vy component is nothing but v cos alpha, vx component is nothing but v sin alpha. Like this you have to be imagined. Next one, that is acceleration. Okay, acceleration. So the symbol for acceleration is a, and the acceleration is further divided into two types based on the definition, which is rate of change of velocity. First one is instantaneous acceleration. Next one is average acceleration. Instant acceleration is given by a is equal simply dv bar by dt. You have to write down. In this particular formula, we have to substitute the value of v bar here, and then we can compute the value of acceleration. And the average acceleration is nothing but average acceleration is equal to net change in velocity to the total time of journey. By taking this particular ratio, one can compute average acceleration and as well as instantaneous acceleration by using this differential formula. And units of acceleration nothing but meter per second square. Dimension formula m0 L power 1 t power minus 2. This is a vector quantity. So in the examination, we have two types of accelerations. First type of accelerations are called as constant acceleration and variable acceleration. What is meant by constant acceleration and what is meant by a variable acceleration? Constant acceleration means object contains some non-zero fixed values of acceleration. Suppose a is equal to 1 meter per second square. Throughout the observation, the system contains acceleration of 1 meter per second square. That is the meaning. Variable acceleration means acceleration is defined as either a function of position or acceleration is defined as some function of time. So depending on the time to time acceleration changes, depending on position to position, acceleration going to be changes. However, the non-uniform motion will falls under accelerated objects only. In the acceleration concept, negative sign plays very important role. Let us see a note. Note number one. Negative acceleration means minus a represents two things. Number one, motion in backward direction. Second concept is decelerated object. Means still object is moving in forward direction but slowly approaches to zero. So there are the two meanings for negative acceleration. So for zero acceleration means again two terms. Either object is at rest or object is moving with a uniform motion where velocity is not changing. Then change in velocity becomes zero. As a result, acceleration also possible to zero. Third one, acceleration is positive. Acceleration is positive means no doubt that is object will be increasing its velocity from position to position. Okay, so in hyperfine in the delta t tends to zero. In such a case, if the change of velocity is not equal to zero and a positive number, then acceleration is positive. If it is negative, then it will become negative. Or you can take object moving in backward direction. That depending on the problem and imagination, you can define this particular case. Example, you are projecting an object, but because of reflection, it is coming back. That means acceleration is negative, displacement is positive, initial velocity is positive. Suppose if the object completely approaches to the starting point, then displacement is zero, initial velocity is positive, acceleration is negative. Now, if object moves further backward, then displacement is negative, initial velocity positive, acceleration is however negative because acceleration is object is accelerating in backward direction. These are the meanings what we have to consider. However, in this particular case, while object is going towards the system, it is decelerating. In that sense, also you can use minus a. Okay, these are the things what you have to use during the reflection of object from wall. Now, the next important concept is equation of motion. So, the equation of motions further here divided into four forms. First one is scalar form, vector form, differential form, and integral form. Scalar form means already we know that V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. In vector form, we will take care of the same symbols. V bar is equal to U bar plus A bar into T. S bar is equal to U bar into T plus half A bar into T square. V bar dot V bar minus U bar dot U bar is equal to 2 of A bar dot S bar. We can use like this. Next, in the differential form means we can use velocity V bar is equal to d by dt of x bar we can use, and acceleration A bar is equal to, we can write down as d by dt of V bar, we can write down like this. And further we can also write down as A bar is equal to V bar of dV bar by dx. We can write down one more formula for the acceleration. And in integral form, we can write down as delta x is equal to integration of v dt, and delta v is equal to integration of a dt, and integration of a dx is equal to integration of v dv. So the concept is this particular three kind of formulas majorly helpful in solving of variable accelerated motion. Variable accelerated motion. That means if the acceleration of the object is variable, then we can use these kind of equations to solve the final velocity or initial velocity or a particular position. What is acceleration velocities? Such kind of equation can be retrieved using this particular integration. Sometimes we have to take the help of differentiation also. Anyways, in the examination, if the vector form or the positions are given means, then we have to use this particular case, or if the scalar values are given means, we can use directly in this particular form. Now, on the other,
An object is starting from rest. Object starts from rest. Then, what are the things you have to take care? Then, displacement proportional to square of the time. Speed of the particle at a particular position proportional to its square root of time. And sometimes we also proportional to t. Next, for example, if the same object starts with a constant velocity, object starts with a constant velocity, then the distance of journey proportional to the time. And the third thing is that if object starts with a constant acceleration, then distance of journey proportional to tq, and further speed of the particle proportional to t square, and acceleration proportional to time. Next one is fourth one. A particle is moving along a straight line with uniform acceleration and crosses the two positions A and B with the speeds of v1 and v2. Then the midpoint crosses with a speed v given by root of v1 square plus v2 square by 2. Example like this. Suppose imagine that there is a train. Okay. Now there is a pole. Train crosses the pole with the speed of v1, and the last thing or last compartment travels with the speed of v2. Then the mid one will try to leave the system with a speed of v is equal to of v1 square plus v2 square whole root by 2 under root. Okay. Next, let distance traveled by the object in nth second. Imagine that this is the x-axis. In this x-axis, we have this is called distance. This is a t is equal to 1, t is equal to 2, t is equal to 3, dash dash dash, t is equal to n minus 1, and t is equal to n seconds. Then distance traveled in the first second is nothing but this is called as distance traveled in first second. And distance traveled in the second means this is the distance traveled in the second, and distance traveled in the third second means this is the distance traveled in the third second. Similarly, distance traveled in the nth second means this is the distance traveled in nth second. So we have like this: distance traveled in the nth second Sn is equal to distance traveled in n seconds minus distance traveled in n minus 1 seconds. This will give you u plus a by 2 or 2n minus 1 during uniform acceleration. If it is decelerated means instead of plus what we have to get here? Minus sign. That's it. In some books it will be represented as u plus a of n minus 1 by 2, where n is nothing but the time where we have to be observed. Next, let Sm and as well as Sn be the distances traveled in the
mth second and as well as nth second. Then in this case, the acceleration of the object is given by a is equal to sm minus sn by m minus n. So one more formula. Next, now let us consider that the object is starting from rest. Let u is equal to 0. When object starts from rest and moving with the constant acceleration, a is equal to fixed and which is not changing. Then the ratio of the distance traveled in the nth second to that of total distance of journey given by 2n minus 1 by n square, or else you can write down as 2 by n minus 1 by n square. Next, eighth one. Now in this case, object initially at rest and moves to the maximum speed of v naught, and then finally it achieves to 0. Now during this case, this is accelerated and the second half will be decelerated. In the acceleration, the quantity is alpha, deceleration is rate is beta of the system. Then the maximum speed v naught called as maximum speed, which is called as maximum speed achieved by the system, given by alpha into beta by alpha plus beta into t, where t is called as total time of journey. Time of journey. And next one is, what is the average speed? Average speed. Average speed is given by alpha into beta by 2 into alpha plus beta into t. And next one is the displacement of the particle during this case given by alpha beta by 2 into alpha plus beta into t square. So by using all these formulas, one can compute 1, 2 and 3. By using these three formulas, one can compute directly without knocking the further quantities in the examination. See, the concept is like this: velocity versus time. So the graph will be generally like this. Initially it accelerates and then decelerates. So from here to here time is nothing but t1. From here to here time is nothing but t2. Then t is equal to t1 plus t2. Where this particular line corresponds for the v naught, called as maximum speed. Maximum speed. And here slope, and this slope will represent alpha and as well as beta. There is nothing but acceleration here and deceleration here. Right, anyways. Now let us consider the next concept. Now, suppose a bullet travels, there is a bullet and it travels through the some wooden plank like this. If the initial heating speed is u and upon traveling some distance, the present velocity will be 1 minus 1 by n of u. That means loss in velocity is 1 nth of initial. Say penetrating distance is x1. That is loss will be 1 by n. Therefore present will be u minus u by n, which is called as final velocity, which is equal to 1 minus 1 by n into u. Then in this case, number of planks required to stop the motion is nothing but number of such planks required to stop the system is n square by 2n minus 1. Next, that means up to here we have to imagine that a single unit of a plank, such identical number of planks are here. Like that we have to imagine. Next, 10th one. If an object changes its velocity by 1 by nth part while moving a distance of x, then the remaining distance is nothing but, so figure is same. What is the remaining distance? Remaining distance means x by n square minus 1. That's the remaining distance before it comes to rest. Next, suppose object is moving with a speed of v and approaches to 0 rest. Then the stopping distance is given by s is equal to v square by 2a. These are the standard observations what I have to take care. Next, now let us consider some important ratios. Suppose object is starting from rest, u is equal to 0, but a is equal to some fixed number. Then displacements in the ratio s1 is to s2 is to dash 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 sn. These are the displacements. That means what is the formula? S is equal to u0 means ut0. Therefore, half at square is there. Therefore, 1 square plus 2 square plus dash 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 n square. To avoid confusion, let us make a whole bracket. Whole bracket means total time of journey. Like that you have to take. And second ratio. Distances traveled in the particular second. S1 is to S2 is to dash 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 Sn. When u is equal to 0 means Sn is equal to a by 2 of 2n minus 1, where a by 2 is fixed number. Therefore, 2n minus 1 is an odd number. That means 1 is to 3 is to 5 is to dash dash dash. We can write down as 2n minus 1. That means regular intervals of time will give you this kind of ratio only. That means let us consider that something like a system like this. Very simple. 1, 2, 3, 4, 5 like this. So distance traveled in the first second, second, third second, the ratio 1 is to 3 is to 5 is to like this we have to take. Now in the examination to confuse you, they will try to give you successive seconds like every 2 seconds, every 2 seconds gap. In such case also 1 is to 3 is to that ratio will be holds good. There is no doubt. Next. Next one is now suppose if this is the distance of journey, then distance traveled, so time taken to travel in the each meter of the distances. So x is equal to 0 here, x is equal to 1, x is equal to 2, like this. X is equal to n minus 1 and x is equal to n meters. Okay. Then in such a case, time of journey means from here to here called as t1, from here to here called as t2, dash 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 t. In such a case, what we have this. So ratio of times t1 is to t2 is to dash 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 tn. In such a case, how to find out? So here 0 means 0 nothing. Here x is equal to 1, which is equal to half a into t1 square. Let us take this is some t1 up to here it is t1. This is 0. Therefore t1 is equal to what we write down here, root of 2 by a we can write down into 1. So therefore this root of 2 by a is a standard unit taken as 1 minus 0. Let us take is to now second. From here means x is equal to 2 means total distance of journey up to here is nothing but 2 meters. Therefore 2 is equal to 1 by 2 into root of what we write down here. So 1 by 2 into 8 square we can write down here. Acceleration is constant t2 time. I need the gap from here to here gap. So that gap is nothing but this value minus this value. Therefore root 2 minus 1. And next one is similarly root 3 minus root 2. So this fragment will be goes on, and we have root of n minus 1 minus root n, sorry, root n minus root of n minus 1. Like this the ratio will be continued to the last numbers.